Okay. Okay. So, I did get a new microphone. It's kind of messed up a little bit. I think you can see it over here. It's taped together. But it looks to be working very well. It's going to pick up all the sounds you guys have until I get another one. That'll have to do for now, but it works way better than the one that's mounted up there. Of course. That's what the microphone does. So anyways, let's get started with statistics. So I'm starting this just so that it'll kind of fester in your mind and you can kind of think about it during the 2 weeks on how we kind of talk about data and stuff. So let's start with now you don't have to stand up for this, but just raise your hands here real quick. Is 99 a good number for you? If it's a good number, raise your hand. Okay? That's okay. If you have your reason, just raise your hand. If you don't, then you don't. Okay? So, what if 99 was your basketball score? Hands? Yeah. If 99 was your basketball score, playing basketball, you're like, yeah? What if it's your golf score? Not good?
I don't play golf.
What if it's your grade in this class?
This is an AP.
Well, this is a presentation I use for AP Stats. What if it's your monthly salary?
99,000.
What if it was your hourly salary? In pennies. What if it's your age?
Nope. I'll be glad to still be alive, buddy.
I say as long as I can still clean my own butt, then I'm okay with 99, right? Once I can't do it, just put me out of my misery. So, thank you. Thank you. Thank you. So the point of those questions is that numbers by themselves are not good enough. And I think for the longest, that's what we're programmed to do, right? Find the answer, find the answer, find the answer. What's the answer? It's just a number. But a number by itself means nothing unless we attach a meaning to it. Okay? Hey, Rue, 12. Exactly, huh? My response is probably like, okay. 62? But they mean nothing, right? They mean nothing without something that's attached to it. So, and what we do in this class is in this part of the class, is that we actually attach meaning to numbers. Okay? And I think your math teacher probably tried to tell you all along, right? Oh, if you find the area of something, don't just say it's 24. It's 24 inches squared or feet squared. Or if the length is 15 centimeters. Length isn't 15. 15 by itself doesn't tell me anything. Okay? Does that make sense? So what we try to do is try to make sense of these numbers. So, and I really like starting with this because it just kind of gives you a whole new fresh look on everything that you've been doing. So, let's talk about statistics. Someone asked, what is statistics? Well, statistics, it's the science of collecting, organizing, and interpreting numerical facts, which we call data. We call these numerical facts data. Notice that facts with an S is plural. Data is plural. The word data is plural. Are we good?
No, sir.
Why? That's it? whole
nice
thing
one.
again? You guys remember that? Oh, man, let's see it again. Yeah, for the longest, huh?
Remember like the first day of school we thought.
Kaylee, Elena, Corey, Jobit. Elena, there you go. Jared, hubble, hubble. Jared.
Oh yeah. Let's see some.
Alright, cool. So, ¿qué estás copiando letra por letra? Okay, so, anyways, statistics is actually one of the newest maths that are out there, okay? We've been doing algebra, well, since the Arabs started it, way back when. We have geometry from, Pythagoras and all that stuff. Really, really old maths. But statistics is fairly new, okay? Now, it's kind of been done informally a while ago, but it's been formalized not too long ago. And so it's a very new branch of maths. It actually started in 1662, okay, by this guy named John Grant. Okay, that's kind of the oldest statistics that we found. And what he started was these things that are called the bills of mortality. And I think they are hilarious. But I like to always show that because, statistics always had a humble beginning. Maths, they always start from something that's supposed to be fairly simple, trying to just make some sense, patterns out of stuff that's going on. So let's take a look at the bills of mortality. Bills of mortality. And I'm just going to grab a few here. Let's go images. This one looks pretty good. You remember that? Let me zoom in a little bit so you guys can see. What this was is John Grant was recording how people would die. How people would die. So if you take a look at these, they're not bad. You've got people that, die of age. I don't know what apoplexy is. Some people die bedridden, they're in bed and they're dying. Cancer, giving birth, cryolomes. But some of them start to get kind of weird, like colic. Anybody know what colic is? That's like a little baby thing, when they're like, they got colic. Convulsion, fever, fistula, I don't know what that is. Flux, not to be confused with flux. Smallpox, king fever, I don't know what that is. Lethargy. Lethargy is it's like when you're sad. You guys ever see your dog get sick and they're like, you're lethargic, you're very sad, kind of like slow and stuff. Plague, rickets. Anybody know what rickets is? And then 19 people died rifing of the lights.
What does that even?
I don't know what rifing of the lights is. Now, some of these are not bad. We had 2 people die from stone. But if you take a look at the bottom ones, these are crazier. We had one person die frightened.
That's a heart attack.
That's the hardest way to die. Like someone just got so scared they got.
Hey, scared him to death.
21 people died of infants. Kids, children.
Dying through birth.
113 people died from teeth.
Suddenly death.
Yeah, and there were some that died suddenly. So you have sudden death, teeth. 3 people died of the truth.
They can't handle the truth.
They can't handle the truth, so they died. And then this killed me. 8 people died of wind.
When you're
Yeah.
really, when you're really
And then
scared.
18 of them died from worms. Worms are pretty vicious, but wind, come on, man.
That's not the kind of wind.
How do you die with sore legs?
There's an E on the end of it.
Windy? No, this is old English, so they write things very differently. For example,
Childbed.
yeah, they don't say giving, at giving birth, they call it childbed. So it's a bunch of different weird.
Drowned.
Yeah, a couple people drowned. But the ones that killed me, I'm like, you died of infants. You died 474 gripey in the guts. They had a serious case of BGs. Don't feel. Don't let it show. So I mean, these are just. One died from a sore leg. I don't know how you guys are, track and stuff. I don't know how you're dying from it. Soccer. I'm so sore. I'm gonna just die. Okay, this one was funny. Spotted fever and purples. I don't know if that was the name of a disease, but if you die from the purples now, I'll just give you red next time.
Rifing of the lights.
That's why I said rifing of the lights. I don't know what rifing of the lights is. I don't think I even care enough to look. I'm just gonna laugh because once I know what it really is, I probably won't think it's funny anymore.
I'm gonna search on it.
But that's exactly how they started. This guy, this mortician type guy, started just recording how people were dying. And that's really what it is. It's trying to get all the data together, all the information, and trying to make some sense of it. What's going on? But as you see, because of that, a lot of these things don't exist anymore, do they? If you're if you got a lot of wind, then we're probably thinking, oh, maybe you got ulcers or something, right? So we're kind of able to diagnose these things. Oh, you got some griping in the guts. Maybe you shouldn't have so much milk or something. I don't know. Maybe they had stones, but that's what. That's the best that they could do back then. Okay? So, right. So it's a bunch of different things that could have been going on, but there was a name for it. But as they start to track these things, they start looking into it. Oh man, you know what? Man, these purples, these purples crazy. They took 190 people. We better take a look at these purples and see what's going on with these purples. So, teeth. Anybody die from scurvy up there? Yeah, one died from scurvy. You guys know what scurvy is, right? Lack of vitamin C.
Actually, no. Actually, it's been proven that
It's actually D.
it's not. That's not the cause of it.
No?
It's just no. It's from because they got it from obviously pirate times, right? It's because they ate too much of it. If you have too much, I think it's if you have too much of it. But
That's interesting.
it was this one show I watched.
All right, well, good to know. So let's get back to here. Bills of mortality. You guys want a few more laughs? Go look at how people were dying back then. I mean, it's like, what? How'd you die from the wind? Maybe it was the smell. I don't know. So anyways, those are the bills of mortality. Now, one thing that you're going to realize here is that in statistics, when we start doing statistics, it's going to be more inductive than deductive. Okay? Now, what does that mean? There's two types of reasoning out there, right? One's called inductive, the other's called deductive. And when we use deductive reasoning, which is what a lot of you guys have done for your math classes now, is that you've been deducing. Someone gives you a rule, and you follow that rule kind of to get to the answer, right? Like if I went and I told you, hey, you know what? Every Friday night at 6 p.m., I'm down at Harkins watching the main event or whatever. I don't know. So if you're like, oh, you know what? It's Friday, 6 o'clock. Where's Mr. Munoz? He's over at Harkins watching the main event. Because I've told you what that rule is, right? That is deductive reasoning. Now, watch this. Listen to what I'm going to do. Can you do the next one?
Yeah.
Good. Okay, stop. You know what was going to happen, right? What's going to be? I was going to clap 5 times. Did anyone give you a rule there?
No.
No. You took in the information and you figured out that there's a pattern here, and you say, oh, next time he's going to clap 5 times. And after that, it's going to be 6 and 7. I got you, Munoz. I know what you're playing. That is called inductive reasoning. Okay? No one told you anything. You just took the data, you analyzed it, and then you made a conclusion based off of that. So in statistics, we do a lot of inductive reasoning. Math should actually be all inductive reasoning. But unfortunately, it's not. Sometimes we don't want to reinvent math. So we just use the rules that are given to us to come up with conclusions. Does that make sense? Cool. So, for now, we're going to have our answers. We're going to know what they are. But in real life, we don't make answers with certainty. Okay? Whenever we're doing statistics and we're analyzing data, we might not always be absolutely convinced that that's true. My analogy to that is trials. Everyone's, I'm sure here's been exposed to some sort of trial, right? And when people go to trial, at the end, when they make their decision, when they come up with the answer, there's two things that they can say, right? We find the defendant guilty. That's one.
Innocent.
No, it's not.
Or
Non-guilty.
not guilty. They never say you're innocent. They never say that. They either say you're guilty or you're not guilty. You're guilty because we have sufficient evidence to suggest that you did what you were being accused of. Okay? Something like that. We have enough evidence to suggest that you did what you are accused of. That's when we find you guilty. They find you not guilty when there is insufficient evidence. If there is not enough evidence, and they call it beyond a reasonable doubt type thing, okay? If there's reasonable doubt, then we can't charge you with this. If there's some way, somehow that could have happened and you're not at fault, then we can't charge you for that. And that's what we're doing with statistics. We're taking the data that we know, and all I can tell you is, you know what? I'm sure that this is what's going to happen. Here you go. Or I can say, here's my suggestion, but I can't be completely certain that this is what's going to be. Okay? Because that's all it really is. Does that make sense? If there are any questions at any point, please let me know, okay? This is going to bug a lot of you guys. This is going to bug a lot of people because they're used to getting the same answer. And they're used to turning to their neighbor and be like, did you get this? And they're like, yeah, I got that. And you're like, okay, because that's what I got too. We're good. But it could turn out that you turn to your neighbor and their answer is not your answer, but they're both still right. Yes. Because our answers are not made with complete certainty. When we're analyzing data, we're simply trying to make a decision. Do I reject or do I fail to reject? Kind of, do I find you guilty or not guilty? That's the only thing we're trying to do. Once I have enough evidence to suggest you're guilty, then there you go. Does that make sense? Many times the answers are not the same, not because the data is incorrect, but because of the human error. If we're working with raw data and we have all the numbers that we have to kind of manipulate, sometimes I don't write a 5, do I? Sometimes I write it a 3 accidentally and I thought it was a 5. Turns out it wasn't. It's like, my bad. You understand that? So sometimes when you're working with data, the human error comes in and we mess up a number. But it's not enough where my solution or my conjecture at the end conflicts. I would still come to the same conclusion. Make sense? Okay, cool. Moving on. And here's the truth, guys. It really does take a lot of common sense when we're doing this. Okay? Think about it in real life. Okay? Cam, I owe you 20 bucks. I don't have $20 to give you. All I got is a bunch of ones.
Good.
So what would you say?
Give me money.
Give me those ones, right? That's common sense. But I don't have a $20 bill to give you, Cameron. All I got is 50 of these ones. I can't give you $20 because I only got ones. I don't have a $20 bill.
Give me 20.
That's some common sense, all right? Give me 20 of those ones. We good to go. We squared. So it really is that simple a lot of times. And I think you've heard me say, math don't like hard. And if you haven't heard me say that, I'm going to say it, and I say it a lot. We don't like hard. The reason why we do math is because we want to make sense of stuff, but we want to make it sure that it's easy. Okay, I want to be able to make predictions, but I don't want to go into all this detail. And that's what we're going to be doing. Don't scare you there. Okay, let's talk about another word here. This word is called a variable. A variable. Now, a variable is simply any characteristic. Okay? Any characteristic that a person or a thing can be expressed as a number or counted. You're used to calling variables x, y, z, theta, omicron. I don't know. That's one of them. But what a variable really is, yeah, inputs, outputs. But what they really are is simply representative of a characteristic. If you're Native American, that could be a variable. If you're Latino, if you're Anglo-Saxon, I don't even know if we still use that. Okay, if you got blue eyes, brown eyes, you're tall, short, wide. These are all variables. Long hair, short hair. They're all just variables. They're just characteristics of something. Okay? Yeah? Of course. You may. How many brothers you got? How many pets you got? How many fingers you got? Hopefully 10. But maybe you don't. Okay, but those can all be variables. Now, data. Data by itself. Those are the numbers that we collect. We study or we experiment. From experiments or from studies. So for example, if I went around and I asked everybody, how many siblings you got? All those numbers that I collect are data. And they're called data because there's many of them. If I ask Ariel, and just Ariel, how many siblings you got? And she tells me 4, that's one number, isn't it? That's one datum. Take a look at the bottom. That is one datum. It's one simple element from the set. All of them together is data. I don't know if you guys ever seen that. The shirt out there, it says, the data are. Get it right. Because people will say, oh, the data is skewed. The data isn't right. Well, data is not singular. Data is a plural word, meaning many. Okay? You could say datum is, the datum is skewed. The datum isn't right. But data by itself is many. It's a plural form of the word. Nintendo? Cool beans. May I continue? All right. There are 2 forms of data out there. Any data you find will fall into one of these 2 categories. And those 2 categories are quantitative and categorical. Now, I want you to add another one here. Because this is the word I use the most. I use qualitative and quantitative. Qualitative and quantitative. Just understand that when I talk about qualitative data, those are categories. Okay? Here's the big difference between the 2. I'll wait a minute for you to write that down. And answer this phone. Munoz. Hey, what's up, bro? Why don't you just put both of them into the E1 that way? Yeah, just change the weights, just like you do with quarter 1, quarter 2. Okay. All right. Okay, so quantitative, qualitative. One more time. Quantitative data is that data that you can do math with. Quantitative data is that data that you can do math with, or you can math it, you can operate on it. Okay? So, for example, if I ask you again, how many siblings you got? Okay? I can take all those numbers, add them up, divide by how many numbers, right? Find the average of it. Okay? Does that make sense? I can do that. Then I can say, oh, the average number of siblings that this class has is blank. That is quantitative data. Okay? Categorical data is the data that doesn't make sense when you do math with it. Okay? So if I sat in here and I said, oh, you know what, I'm going to find out how many people are Latino, how many are white, how many Native American, how many are African American, and how many are other. Okay? And then I'm going to take all that data, I'm going to average it, and I'm going to find out that the average person in here happens to be Native American. What? How did you add that? Can you tell me? Can you explain how I added that and you got what?
Yeah, racism.
Yeah, darn racism. It doesn't make sense, okay? You cannot find the average of an ethnicity that way. Does that make sense? Okay? And you know, for starters, how do you add up Latino, Native American, African American, and all those categories, right? Does that make sense? Religion? It's religiously. You do it very carefully, Mr. Munoz. Make sure to carry the one. You can't do that, okay? It doesn't work. So that other type of data is the stuff that falls into categories. Okay? Make sense? So you got categories, and then those that are numbers, and I can operate on them. Everyone cool with that? Okay, so let's do a little test here real quick. Here's, if I did a rating system of superior, good, average, and poor, would you say that that is categorical or quantitative? Categorical, right? You fall into a category. That's it. Okay? Everyone understand that? That is categorical data right here. How about this? How about time in seconds to run a mile? Quantitative. I can add all those times and find your average time, correct? That would make sense. Social security numbers. That was a trick question in there. This is actually quantitative. Okay? First three numbers of your social security number tell me what state you were born in. The next two numbers tell me what county you were born in. And the last ones tell me which hospital you were born in. This is Munoz. Answer. Yes. Correct. So you got the same time as everybody else. I know what you mean. Unless it's in an IEP, then we'll allow more. Right, on IEP that says more time on assignments. That's it. Thank you. Alright, cool. Moving on. How about this one, guys? Students' test grades ranging from 1 to 100. Quantitative, right? Awesome. How about the heights of people I record in inches? Quantitative. Zip codes.
Quantitative.
Categorical. You got that real quick, huh? Zip codes tell you where you live. It's a category. Okay? I can't add up all the zip codes and say the average city you live in is Los Angeles. Well, what? No. Okay, how'd you come up with that? How about the percentages of students in each class who master a particular skill? That one's categorical. This is why. I know, and the percentage is the one that kind of goes, go ahead. Right, so if you mastered it, now here's the thing. You mastered it, or you didn't master it. It's one or the other, right? And that's it. Cool, so you guys kind of get the idea there? Here's what I was talking about earlier. If I took a count and I said, you know what, I'm going to label white people as 1, African Americans as 2, Asians as 3, and 4 is other. And here's how many people I got. So I got 23 white people, 19 African Americans, 14 Asians, and 4 other. And I found out that the average person will happen to be African American. Where's that Asian guy at? No, this is just a sample slide. It's not this class, bro. Right? But if I did that, I add up all the people, I divide by how many people I got, and I got an average, don't I? And my average was 1.98. 1.98 means that you are African American. So the average person in this lot of people is African American. Obviously, that's not true because the data is categorical. You can't operate on it. Okay? Cool. Moving on. Another reason we do statistics, Pablo, Elisa. Another reason why we do statistics is because we don't want to be lied to. Okay? Take a look at this slide. This is actual data from Williamson County. And here's what they found. They found that if you're 35 years and older, you got 15,000 tickets. If you're under 35, you got 10,000 tickets.
What's that?
And ticket, like the cops pull you over, you got ticketed. Okay? And that's very true. That's exactly what happened in this county. And here's what kind of bothers everybody. It's like, you know what? In Williams County. Now here's what happens. Here's what really bothers people is that if you are under 35, you pay more in insurance premiums. If you are under 35, you pay more in insurance premiums. However, old people are the ones that are getting more tickets. How is that even fair?
They can't see. They're deaf.
Wow.
Oh, wait, well, they're getting blind.
That's in the U.S., bro. Go ahead. But you know what? Here's what's... Doesn't matter what it says. If it says Williamson, or if it says Casa Grande, or if it says Pinal County, or Pima County, it would all be the same. You would get very similar results. Yet the insurance companies use this to say, man, you need to charge these people more money. Josh? Why do you think that's that? Why do you think that would be good evidence for insurance policies? Does that seem fair to you? This is true though, but the insurance companies charge younger people more for insurance. How is that fair?
It is.
Elena? What? But they have more tickets. If you're reckless, you get a ticket, don't you? No, but we're talking about the times you get caught. But everybody has the same chance of being caught, right? But you got less tickets, Kanan. How is that even legit? People that are less than 35 years old get less tickets, but we pay more in insurance. They're the ones that work. Okay? I know you know. But I want them to think about it because this is exactly what I'm talking about when we do statistics. You're looking at data and you're trying to make sense of it. Am I misleading you? No. But you're not thinking about it in the real world idea, in the common sense world. Ms. Vasquez, you want to add to this? Why? What's going on?
Because
Hold on.
35 years and older, it covers more of an age span, whereas the 35 years and under only goes from the age of 16 to 35.
Oh, so they have more years to get to.
How old are you?
Does that? Well, you didn't ask a woman that. Did everybody catch that?
Yeah.
If you're 35 years and younger, does everybody that's under 35 drive?
No.
Everyone under 35. Does everyone under 35 drive?
No.
No. Which age group does not drive? 0 to
15.
approximately 16.
Yeah.
That means that this is only 15, what is it, about 20 years? 20 years worth of people, isn't it? While up there, they can go all the way up to 100 years old. You see that big gap there? So, no, they get less tickets. We get more. And that's why, well, that's the way it is. And that's why insurances charge more money. But that's real data there that we're trying to make sense of. Okay? But you see how you had to have some common sense to figure it out? No? Nick? You don't have common sense? I'm sorry. You're going to be hurting. This was very sad right here. This, when I saw this, I was just so crushed that half of the kids in the U.S. are below the national average. Half of the kids in the U.S. are below the national average. I was like, wow, half of the kids are below the national average. How does that make you feel, Jared?
That is very frightening.
That is very frightening, isn't it? Elisa, what do you think?
The national average for what?
Student scores on their national tests.
Yeah, that is very frightening, actually.
That's very frightening.
It is. Once you think about it.
Guys, stop. You guys can't continue to do like last semester. You're going to end up in the same position, so please focus. Again, that is some shady data. When you see that, you should be going, duh. Duh. Why? Let's say this is my distribution of scores. Right in the middle is the mean. It's the halfway point, right? What percent of the people are on this side if this is the middle? Which is how much? Guys, this is just a fact. That's the way any test works. Okay? Half of you guys are going to be the bottom half. Half of you guys are going to be the top half. There's always two halves involved because two halves make the whole. So when they say half the kids are below the average, well, yeah, because the average is where? In the middle.
So you're not sad?
It's a joke. I'm not sad. I expect that to happen. Okay? The average is supposed to be in the middle. It splits into two halves, the bottom half and the top half. What percent of the people are in the bottom half? Half of them. This one's kind of funny. I hate doing this one. Oh, I love doing this one.
You say you hate.
I hate and I love this slide right here. This is the number of deaths by drugs.
So cocaine for the
Let's not go there, please. 400,000 people die from tobacco every year. 90,000 people die from alcohol. 8,000 people die from cocaine. And 6,000 people die from using heroin. Okay? So, and you're saying you think they got the numbers mixed. That's what I would be at first, like, that can't be right. That can't be right. But it is right. It's true. It actually came from, the mathematician reads the newspapers. It was an article that presented data from a mathematician.
Wait, if you said that you don't think it's that, then what do you think it is?
Oh, I think that's correct. That is correct.
That is correct.
That is correct. Okay, someone said, I don't think that's right, but I asked, why do you think? Okay?
Because the way I think it, I think heroin should be 400,000.
You think the heroin should be at top and tobacco should be at the bottom?
And alcohol should be
That's not true, though. Well, this is a fact, though. More people die from tobacco than from cocaine. Now, let's put our minds to this. Let's look at the common sense. Why do you think this is true? How many people use tobacco? A lot. How about that number compared to people that use heroin?
How are we supposed to know that?
That's common sense. I mean, you think about it, not a lot of people use heroin, do they? Okay, we know this for a fact. I mean, these are the easiest to get, isn't it? Tobacco? I mean, you gotta be what, 18?
Yeah.
Here, I mean, that's gotta be a special process. That's homebrew stuff right here. Right? That's you, the bathroom and the spoon. So, the reason why less people are dying from heroin is because less people are using it. However, this could be almost 90% of the people who use it. While this is probably only 15% of the people who use it. Okay? But those are just solid numbers. Okay? Again, we're trying to make sense of this. Trying to make sense of this. Because I don't know about you, but I don't want to be lied to. Don't want to be lied to. There was a census done in China. 1 year, they had 28 million people. And then they're like, I don't know, something's going on. And they redid it. They had 105 million. What? You think? Okay. Again, now look at this one. This has to do with facts. Tell me which one you think scares you a little bit more. 1 out of 100,000 citizens in the U.S. have been diagnosed with the bird flu.
What is bird flu?
That's when the birds bite you. Yeah, and then you get the flu, and then you start growing feathers and you die.
Is that like the
You can also get it from eating eggs when you fry them.
Yep. Don't do it too often.
Don't eat fried eggs, because
I love fried
Is that how they died in Texas?
no, I'm lying. There's no such thing. It's a strain. They just called it the bird flu. And actually, I think they say it did come from the birds. They kind of mutated. But anyways, here's what we're looking at. 1 out of 100,000 citizens in the U.S. have been diagnosed with the bird flu. 3,000 cases of the bird flu have been diagnosed in the U.S. Which one sounds scarier to you?
A,
B. Go B.
B.
Go B.
It's only 1 out of 100,000.
both.
I'm not the one.
I think both.
I'm not the one that's sick. I can't be sick. Are you sick?
No.
No. Right? So that doesn't sound too bad. Man, it's 1 out of 100,000. I mean, that's a lot of people. I'm like, no one's going to get sick around here. But if you look at the other one, they say, man, there's 3,000 cases of the bird flu. Maybe I got it.
That's kind of scary because you don't know you got it, but you don't know you.
So here's the bottom line, though. Thank you. Thank you. Well, here's the truth about both of those statements. They're both accurate. They're both accurate. Okay? They're both accurate. So, it just depends how you say those things. That's going to make people go, let's see here. This was a good one. This was funny.
Hold on, let's see.
This is just a kind of a fun fact. Guys, stop. Packing it up. I've got to the bell. You start packing up a minute early, I'm going to take a minute from you after the bell. I don't know if I want to do that slide anymore. Oh, I was almost done. Let me go back to this one here. Actually, that's not even the point anymore. You kind of killed the mood already. I'm done.
You guys.
That's the intro. Tomorrow we're going to do a little bit more. Make sure that you're here so that you guys get the notes for that. And I will see you tomorrow.
All right.